equal and opposite. Making sure if you're doing it with a group that you know where yours are. And again, 2 rings. The first one on, and then the second one. So that now if you wanted to, you can't even take this out of the rotor because this one fixes the rotor to the centrifuge itself. This is an SS34 rotor. So again, we're selecting the rotor by pushing the rotor button and then the cursor down till we see SS34, which is number 5. So we say 5, enter. And then we use the cursor button to say what speed do we want to go. And we had said we want to go 12,000 RPM. And we want to go for 20 minutes. And we're going to start it. Okay, so now we have our pellet. I've already resuspended the first pellet in buffer D, and so this is our second pellet that I'm resuspending in buffer D. I've already added the contents of the first pellet into the second pellet, and I'm still resuspending everything with that buffer D, that 2 mils of buffer D. So just again, pipetting up and down to resuspend everything. And then just like we did after the first time, after we made our chloroplasts, we saved a 0.2 mil sample. This time we're also going to save a 0.2 mil sample. So again, setting it to 200 microliters, saving a 0.2 mil sample, and putting it into our second 15 mil tube. So now we have a 0.2 mil sample of our isolated chloroplasts, and now we have a 0.2 mil sample of our isolated thylakoids. And what we have here is our isolated thylakoids, and you're going to be saving these until next time. What we're going to be doing with those in our detour procedure, we're going to be looking at the yield that we get between the chloroplasts and the thylakoids, and we're going to be adding acetone so that we can determine the concentration of both our chloroplasts and our thylakoids. But it's important for the thylakoids mostly because we want to be able to dilute our sample that we just added the buffer D to 1 mg per mil of the chlorophyll concentration. And if you refer to the first lecture for this experiment, you will see that same formula that we're going to be using to determine our concentration for our chloroplasts and for our thylakoids. So in this procedure, our detour procedure, we're going to be determining the chlorophyll concentration in either our chloroplasts or our thylakoids. So for both of them, you have saved a 0.2 mil sample. To this 0.2 mil sample, you're going to be adding 4.8 mils of the 85% acetone. And remember from lecture that the reason you are adding 85% acetone is that you have to have a certain amount of acetone to be able to dissolve the membrane. And remember from lecture, there's 4 things that the acetone is doing. It's an excellent test question, so make sure you remember what 4 things the acetone is doing. So here we have acetone having dissolved our membrane and solubilized our chlorophyll, 2 of the things that it's doing. And we have our protein that has been denatured, and we need to get rid of our protein. So we're going to take our protein over to a tabletop centrifuge to spin it down. Okay, so you can either do this with a partner when you are doing your chloroplasts, or you can do your chloroplasts and your thylakoids at the same time, whatever you prefer. In either event, you're going to put them into the centrifuge. Now, when putting samples into the centrifuge, you want to make sure you're putting them in equal and opposite in terms of their sides. So I'm putting 1 in this side and 1 in that side, but that's not enough. If I put, because we don't have any holes that are directly in the middle, if I put 1 on this one into this side, then this one has to be in to that side. So like if you're using this swinging bucket right here, there's no hole right there in the middle. So if you put something in this hole right here, then the other one would have to be in this hole right here. You can't put both of them on this side or both of them on this side. And so you want to make sure that they're equal and opposite. Then you're going to close the lid on the centrifuge. In this one, you're going to lock it, and it's set to 4 degrees Celsius. The lights just went out because we're not moving enough. And you're going to just set it for a couple minutes of time. So it's going to go for about 3,300 RPM for several minutes, and then it will spin down. When we finish spinning it down, you will see that there is a small pellet right in the bottom of the tube. That pellet will have sort of a gray color to it, and that gray color, that is your denatured proteins that you have now spun out of solution. But remember that the acetone is being used to solubilize our chlorophyll, so the upper solution will still be green because the chlorophyll is still in that upper solution. Okay, so you've just taken your sample out of the centrifuge, and you see here you have a gray pellet at the bottom of the tube. This is all of your denatured protein from your thylakoid or from your chloroplast, whatever you have in this sample. And you have solubilized the membrane, you've solubilized the chlorophyll, and the chlorophyll is in this sample. If you were simply to put this into your spectrophotometer now, you would be out of range of your spectrophotometer. So you need to dilute it again. So you're diluting it this time with 80% acetone. The first time, remember, you used 85% acetone because your initial 0.2 mil sample did not have any acetone at all in it. But now our sample is probably about 81, 82% acetone in there, because part of it, remember, is an aqueous solution. And so now you just need 80% solution, 80% acetone minimum to be able to keep your chlorophyll in solution. So to that end, we have added 4.5 mils of 80% acetone into a second tube, and you're going to take 500 microliters of your first solution, and you're going to add it into this second solution. So now you've basically diluted it so it's a lighter green. You don't need to, again, vortex or anything like that. It's just a simple inversion to mix. So now this is a color that can be picked up by the spectrophotometer. So you're going to be reading it at 2 different wavelengths. You're going to be reading this at 663 and 645 nanometers. So you can just set your spectrophotometer to the first wavelength, 645 nanometers in this case, although it does not matter which one you use. And here you have a cuvette. This is the part of the cuvette that the light will go through right down here. This is a 1 mil. See how it's very narrow right here. And then it's wider up at the top. It's okay to touch the cuvette at the top. You don't want to touch it where the light will go through. You want to make sure that you know where the beam of light is going through on your spectrophotometer. Different spectrophotometers are different. So just because on this spectrophotometer, my light beam goes this way, does not mean that all spectrophotometers are going to work the same. So you have to actually check. So in this case, the light beam goes through here. So we want to put it so that our 1 centimeter path length right here is going to have the light beam go through it. So I'm going to put that into the spectrophotometer all the way down. Now, I'm going to put some acetone in there. You don't want to do this in advance because acetone will dissolve the plastic that these are made from. So you're just going to put around 1 mil of acetone into your cuvette. So you've got 1 mil of acetone in there. This is your blank. So then on this particular spectrophotometer, you can say measure blank, and it will reset it to 0. Come on, measure blank. It's thinking about it. And so now it says 0. So now to read your sample, you need to bring this out. Just get rid of it, throw it away. Put your new sample in here that you have newly diluted with acetone. Just pour about 1 mil in there. Close the lid, and you're going to get your reading of 0.075. So you're going to be doing this procedure with both your chloroplasts and your thylakoids at both 645 and 663 nanometers, and you're going to get readings, and then you're going to put it into the formula that you were given in the lecture.